Hello, welcome back from break. I bet you're so excited to start your first algebra homework assignment in 2014. It's a big deal. So to start this off, we're going to be working with evaluating and graphing polynomial functions and using the fundamental theorem of algebra. So it says a polynomial function is a function of the form f of x equals a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus to be continued, and then plus a sub 1 times x plus a sub 0, where a sub n does not equal 0, the exponents are all whole numbers, and the coefficients are all real numbers. So now, as a reminder, the exponents are these little n's up here, and those are just always going to be whole numbers, your 1, 2, 3, 4, 5. And your coefficients, those are the numbers that are in front of your x, remember? So those are all going to be real numbers. Now, now these are just some terms that we'll have to know as we go throughout this unit. Our leading coefficient, what that is the coefficient with the term with the largest largest exponent. Now, all that's saying is our leading coefficient is going to be the number that's in front of the variable with the largest exponent. So, for example, if this exponent is the largest, then our leading coefficient would be this number here. And our leading coefficient is always going to be the number in front of our variable when it's in standard form, which we'll talk about. So our constant term is our term without a variable. So for example, that would be if we had a function where it was 2x to the fourth plus 3x plus 4. This 4 would be our constant term because there's no x with it. Our degree is the highest exponent of the function, and this will, so if we're looking at this, our degree in this case with all generic numbers or letters would be n, because that's the largest exponent there. Our standard form is just when the terms are, that's weird, written in descending order, that's supposed to be. So with the largest, not highest, largest to smallest exponent. Alrighty, so that's when it's in standard form. Now here's a little table that will help you kind of remember what your graph is going to look like. So if our degree, so our highest exponent of our function, is 0, that is going to be a constant graph. So in our case, that would be like f of x equaling 2. So this is going to be a horizontal line. It's a constant number. If our degree is 1, that would give us a linear graph that just went away for no reason. Okay, so then that would be like our f of x equals 1/2 x. There's only, this is like a x to the first power there, so that would give us a line, a straight line. If our degree was 2, that would give us a quadratic. And that is going to give us our U-shaped. We talked about that before. If our degree is 3, that gives us a cubic. So, oh, I didn't get an example. So for a quadratic, that would give you like your x squared. And this would be 3x cubed. Okay. If your degree is 4, that is a quartic. So that would be like f of x equals, doesn't matter what number, 2x to the 4th. Okay. So moving on, as we look at our end behavior, it's the behavior of the graph as x approaches positive infinity. We write that as a plus sign for positive, and then our infinity sign, or negative infinity. Okay, so in the notes, I won't be writing out positive infinity. I'll just be doing the plus sign and our infinity symbol. Okay, same for negative. Now our end behavior, if we're looking at the graph f of x equals x, that just looks like a line like this. Okay, so if we're looking as f of x is as that approaches our positive infinity, our x value is going to get really big. Okay, so now all this is saying is as our function and that's like our y, as our y's get really big, our x values get really big. Okay, and where our x values are going, that is our end behavior. So this is the key part that we're looking for the end behavior. So if we're going to negative infinity, where does our x go? Where does our x approach as our y's go to negative infinity? Oh, our x also goes to negative infinity. Okay, so this would be our end behavior for our f of x equals x graph. Now if we're looking at f of x equals negative x, it looks like this. It's going to be a little bit different. It's going to be f of x as that approaches our positive infinity. So as our function goes up, increases, what does our x values do? Oh, they become smaller and smaller. They approach negative infinity. And as our f of x approaches negative infinity, so as they go down, what happens to our x's? Oh, they get bigger and bigger. X approaches positive infinity. Alright, now looking at our function f of x equals x squared, looks like our u shape, as our f of x, as our y values, go to positive infinity. So as our y values increase, what happens to our x values? Oh, well, our x values could also be going to negative infinity as our y values increase, but in this situation, our y values are never going to go to negative infinity, right? So, but we have to consider our x values also could go to positive infinity. So our end behavior is it could go to negative infinity or positive infinity for our x squared, and both of these are positive. Okay, now for this last one, f of x equals negative x squared, that flips it over so it looks something like this. Now this is going to give us as our f of x, as our y values approach, can they ever approach positive infinity? Well, no, they're never pointing up, so it can only go to negative infinity. What happens to our x values? Oh, well, our x values could go all the way to negative infinity, or as our function approaches negative infinity, our x values can also approach a positive infinity. Okay, so this is just determining the end behavior. So what does our graph look like as our x's get really big? Okay. Now, using your graphing calculator to graph the following functions, then describe the end behavior of each graph. Now, to do this, when you plug this into your calculator, I'll give you a few seconds to get those out and do that, and then I'll show you what you should get. Alright, so when you put in your f of x equals x cubed, it should look like this. So, if we just sketch this graph, it looks something like that. And as a reminder, when you plug this in, if I go to my y equals, there is a cubed button. To get to that, you could hit math, and then it's your third option down. Or you could have just hit your exponent button and hit 3. Okay, either way would have worked. So when we do this, as our f of x is that, and we're looking, okay, our x is approaching negative infinity. So as our x is going to the left, what's our function doing? Oh, our function is going downwards, so then that means our f of x is approaching negative infinity. Now to fill in this blank, as our x approaches positive infinity, so as our x is increasing, what's happening to our y's? Oh, our y's are getting bigger, so they're approaching positive infinity. Okay, so now let's look at our graph of f of x equals negative x cubed. So if you plug that into your calculator, I'm just going to quickly do that. Second insert, negative. You should get a graph that looks like this. So it's just pointing the opposite direction. So looks something like this. Okay, so now if we're looking as x approaches negative infinity, so as x gets smaller and smaller, what's happening to our function? What's happening to our y's? Oh, it's increasing, so that's positive infinity. And then as our x gets larger, our f of x goes to negative infinity. If you look, our end behavior is switched for our graphs, or for our function, because of this little negative sign there that switches everything. So you got to be careful when you're thinking about this for your end behavior. And also, as your x's get really big, your graph gets lower and lower numbers. That's what this negative does. Okay, it makes it, before, when your x got really big, your y's got really big. Now as your x's get really big, your y's get really small. They get really low. Okay, so that's what that negative does. If we move down to this x to the fourth, let's plug this into our calculator. So clear, and then clear. So we have our x, we go that root 4, hit graph. Now this kind of just looks like a parabola, but I'm going to zoom in just a little bit, okay? So I'm going to change my window to be -5 to 5, -5 to 5. Oh, you can't quite see it. I'm going to zoom in a little bit more. I'm going to change my y's. You know, I'm going to leave it as -5 to 5 and -5 to 5, so that way you can get a good picture. Now what I wanted you to see here is this kind of looks like a parabola, but it's kind of flat right in this region. That's what this x to the fourth does. It just flattens it out a little bit here, okay? So if we were to graph this, it just looks like a flattened out parabola a little bit there. That's what that looks like. And if you had to guess what would this negative x to the fourth look like, well, that's just flipping it. It's the same thing, it's just flipping it there. Okay, so as our x goes to negative infinity, what's happening to our graph? Oh, our f of x goes to positive infinity. What about as our x gets really big, goes positive infinity? Oh, that also goes to positive infinity because they both point up. Now, in this case, as our x gets really small, our f of x gets, That also goes to negative infinity. And as our x gets really big, that is also going to go to negative infinity. Now make sure you click on the part 2 of this video.